Let us derive the field expressions in the TE mode analysis. Myself Dr. V.V. Sethi, Associate Professor, Department of ECE. So, in the previous session we have seen what is a TE wave equation, that is we have derived what is Hz. Hz is equal to some C cos m pi by Ax cos n pi by By e power j omega t minus gamma z. Now, using that expression, let us derive the field expressions in the TE mode analysis. So, at the end of the session, the student is able to analyze different modes that are propagating in the rectangular waveguides. So, now let us see what is the field expressions. So, let us first, I will write the what is the for our reference, where write what is the TE equation. The TE equation is Hz is equal to some constant cos m pi by Ax cos n pi by By e power j omega t minus gamma z. So, this is our TE wave equation what we have derived, and this is the equation number 40. So, now from this wave equation let us derive the field expressions. So, as we have explained what is the field expressions Ex, Ey, Hx and Hy. These are the field expressions, and let us write the field expressions once again. So, let us revise that as it is V with respect to x, the first component is minus gamma by h square dou Ez by dou x. Okay. For all the cases, the first component is minus gamma by h square, it is dou Ez by dou y, and this is minus gamma by h square dou Hz by dou x, and as it is h with respect to y, minus gamma by h square dou Hz by dou y. This is the first component, and coming to the second component, here it is minus j omega mu by h square dou Hz by dou y, because already this is Ez with respect to x, then this is Hz with respect to y, and this is plus j omega mu by h square dou Hz by dou x plus j omega epsilon by h square dou Ez by dou y minus j omega epsilon by h square dou Ez by dou x. Anyhow, as we are deriving the field expressions for TE wave equation, so Hz is represented by equation 40 and Ez is equal to 0. As Ez is equal to 0, in this the first term will become vanish, here also the first term will become vanish, and in Hx the second terms will become vanish, Hx and Hy. So, here Ex is nothing but is equal to minus j omega mu by h square dou Hz by dou y and this is j omega mu by h square dou Hz by dou x. Here Ez components will vanish, becomes minus gamma by h square like this. The field components will vanish, and these Ez terms will become 0, and we are going to get Hz terms. So, now let us derive these field expressions by deriving this Hz with respect to x and y. So, let us see what is the differentiation of this Hz with respect to x and y. I am writing Hz again, C1 cos m pi by a x cos n pi by b y e power j omega t minus gamma z. Now differentiating this hz with respect to x. With respect to x, the y and z becomes constants. So c cos n pi by b y e power j omega t minus gamma z into differentiation of this cos m pi by a x, that is m pi by a into minus m pi by a into sin m pi by a x. Okay, and differentiating hz with respect to y, we get c cos m pi by a x e power j omega t minus gamma z into differentiation of this cos term, that is cos n pi by b y becomes minus n pi by b into sin n pi by b y. So let us substitute this dou h z by dou x and dou h z by dou y in the field expression. So we get the field expressions. So what are the field expressions? Let us write first Ex. So what is Ex? Ex is equal to minus j omega mu by h square dou h z by dou y. So that is, let us substitute this. Here is a minus and here is a minus. So we write it as j omega mu by h square into c into n pi by b into cos m pi by a x sin n pi by b y into e power j omega t minus gamma z. So this is the field expression with respect to x. Ex is equal to j omega mu by h square c n pi by b cos m pi by a x sin n pi by b y e power j omega t minus gamma z. Similarly, we can find ey, hx and hy. So let us see what is ey. So for ey, we need to find j dou h z by dou x and we have to substitute at the here j omega mu by h square. So that means we have to substitute this dou h z by dou x there. So let us write what is ey. So ey is equal to minus j omega mu by h square c, okay, and we have to substitute m pi by a into sin m pi by a x cos n pi by b y e power j omega t minus gamma z. Right. So this is ey, and then we can get what is hx. Right. If you see for hx, hx is equal to minus gamma by h square dou h z by dou x. So instead of minus j omega mu by h square, if you write minus gamma by h square, we will get dou h z by dou x. So minus gamma by h square c here minus m pi by a, so that becomes plus sin m pi by a x cos n pi by b y e power j omega t minus gamma z. And for hy, okay, so hy we get it as minus gamma by h square dou h z by dou y. So gamma by h square dou h z by dou y, that is c n pi by b cos m pi by a x sin n pi by b y e power j omega t minus gamma z. Okay, so that is hy. So we have obtained the field expressions Ex, Ey, Hx, Hy using the TE wave equation. In all these equations we can see that it is some multiple of either m or n. So that means TE modes we are having m, n, where m and n are integers, and suppose if this m or n has become 0, or suppose say m is equal to 0 or n is equal to 0, as m is equal to 0, Ey and Hx becomes 0, and if n is equal to 0, then Ex and Hy are becoming 0. So all the field components will vanish for m is equal to 0 and n is equal to 0. Not only this, if you consider, so all the remaining field components will vanish. So this T00 mode or TM00 mode does not propagate through the rectangular waveguide. So the field components has to be defined for the modes to be propagating through the rectangular waveguide. If not all the field components, at least one or two field components has to be defined in addition to the Ez and Hz, Ex, Ey, Hx or Hy. Any of these field components has to be defined, then only that particular mode is going to propagate through the rectangular mode waveguide. So whether it is TE wave equation or TM wave equation, the modes that are propagating in the rectangular waveguide should be all the field components to be defined in the propagation, then only the modes will be propagating in the rectangular waveguide. So coming to the summary, now we have seen the TE wave equation and has derived all the field expressions Ex, Ey, Hx and Hy based on this TE wave equation.